In coordinate geometry, in order to prove something true, I need to use formulas. If I want to prove lines parallel, I want to use the slope formula. And if I'm going to use the slope formula, I need to find the slope of both lines and show that those two slopes are equal. In plane geometry, in order to prove something true, I need to write a proof. In order to write a proof, I need to justify every statement with a theorem, a postulate, a property, or a definition. So if I want to prove lines parallel, I better develop some theorems and postulates that prove those lines parallel. If I look at all the postulates and theorems that involve parallel lines in a transversal, all of these start with lines being parallel, cut by a transversal, and concluding something about the angles. If I switch the conclusion and the hypothesis around, I'm going to actually prove that I have parallel lines. If I write the converse of the corresponding angles postulate, I'm going to prove that I have parallel lines. If I can prove that my corresponding angles are congruent, then I can conclude that my lines are parallel. Be careful, not all corresponding angles are congruent. If they are, then my lines are parallel. That's the corresponding angle's converse. If I look at the original postulate, I'm starting with my lines being parallel. I know that the lines are parallel and concluding that the angles are congruent. The alternate interior angle's converse. If I can prove that my alternate interior angles are congruent, then I can conclude that my lines are parallel. Similarly, if I can prove that my alternate exterior angles are congruent, then my lines will be parallel. And the last converse, if I can prove that my consecutive interior angles are supplementary, then I can conclude that my lines are parallel. In order to prove that I have parallel lines, I need to figure out something about the angles. Let's look at a proof. I have 4 lines, M1, M2, L1, L2, and 3 angles labeled. And I know that M1 is parallel to M2, and angle 2 is congruent to angle 3. And I want to prove that L1 is parallel to L2. Well, it's going to be that is true. So how do I write a proof that proves that? In order to prove that L1 and L2 are parallel, I need to prove one of these things true. So I need to look at my picture. L1 and L2 have 2 transversals. If I look at transversal M2, there's only one angle on M2. If I look at M1, there's 2 angles. And angle 1 and angle 2 are alternate exterior angles. So if I could somehow in my proof prove that angle 1 is congruent to angle 2, then I could conclude that L1 and L2 are parallel by the alternate exterior angles theorem. So ultimately, that's my goal. In order to prove this true, I need to prove that angle 1 is congruent to angle 2. I want to get from here to here. So how do I get here? Well, just because angle 1 and angle 2 are alternate exterior angles, that does not guarantee that they're congruent. I need to somehow get these angles congruent to each other for some other reason. Well, if I look at this second given, I already know something about angle 2. It's congruent to angle 3. So let's look at my first given. M1 is parallel to M2. I know that that is true. And since my lines are parallel, I can use any of these theorems and postulates. So since my lines are parallel, all of these things are true. So let's look at M1 and M2 and the angles. If I look at L2 as a transversal, I only have one angle on the transversal L2. But if I look at L1, I actually have two angles on that transversal. And these two angles, 1 and 3, are corresponding. And since my lines are parallel, my corresponding angles are going to be congruent. I can conclude from this statement that angle 1 is going to be congruent to angle 3. Now if I look at this statement and this statement, angle 1 is congruent to angle 3 and angle 2 is congruent to angle 3. That must mean that angle 1 is congruent to angle 2. I can combine those two statements to make this statement. This is the flow of my proof. I just need to write it as a two-column proof. I'm going to start with my first given. Because my lines are parallel, my corresponding angles will be congruent. That's the corresponding angles postulate. I can also write the corresponding angles postulate this way. Parallel lines imply that I have corresponding angles congruent. I can write this same reason either way. Okay, I've used this given as far as I can go. Let's hop to my other given. Angle 2 is congruent to angle 3. Well, if angle 1 is congruent to angle 3 and angle 2 is congruent to angle 3, that must mean that angle 1 is congruent to angle 2. Now if I look, angle 1 and angle 2 are alternate exterior angles. But that's not the reason that they are congruent. They're congruent for a different reason. The reason that they're congruent is by the substitution property. I'm taking statement 3 and plugging it into statement 2 to create statement 4. Anytime that I see an angle 3, I can replace it with angle 2. Since angle 1 and angle 2 are congruent and they're alternate exterior angles, that proves that my lines are parallel. Why? That's going to be the alternate exterior angles converse. The converse is the one that allows me to start with my alternate exterior angles being congruent and conclude that my lines are parallel. I can also write the converse this way. My alternate exterior angles are congruent. That implies that my lines are parallel.